In this video lecture, we'll see the working of ADC, that is analog to digital converter. Analog to digital converter. Now, in case of analog to digital converter, we have input as analog signal, and there is a sample and hold unit, which is given to ADC, that is analog to digital converter, and we get the output as digital signal. Now let us see the conversion process. This is not there. This is the sample and hold unit, and this is ADC. The output is digital signal. Now we want to understand the working of this sample and hold unit. We know that analog signal is a varying type of signal, something like this, can be any form. This is with time, and this is the analog signal. Some can be voltage or it can be current also. Let us say this is voltage VIN. So this is a continuously varying signal with time. We want to convert this into digital signal. Now in case of ADC, there is a clock signal which gives out the pulses at a specific period of time. This is the clock signal. So clock signals are given at a particular discrete period of time, maybe in milliseconds or microseconds. So these are the clock signals. This is also with time. Now see, this varying signal is sampled at this clock signal. This is the clock signal, and this is sampled. And in the sampled and hold unit, this is a circuit which consists of capacitor and switches like transistors. You get the output which is held for that period of time. Suppose say this is the input. So the signal is held by the capacitor. The charge is held until the next signal comes. The next signal comes here. Then it is again held for that period of time. Okay. Then again it is another this signal until it reaches to this signal, which is at a lower value. And this is approximately the representation of the digital signal. This is the sample and held signal. It is a digital representation for the analog signal. Now we'll see the conversion process. Different types of methods are used. One is successive approximation, then dual ramp method, then flash. Like that, different methods are used. We'll see successive approximation method. In case of successive approximation method, you have got a comparator. This is a comparator. Input signal is coming to the comparator. This is a clock signal and a gate and a successive approximation register which gives the output digital signal. This output signal is compared again back to the comparator by using what is called as a DAC, that is internal digital to analog converter. So there is also a digital to analog converter which gives input to the comparator when the voltages are compared and it is given. Now in this process, what is done, when the input signal comes VIN, the most significant bit is made 1. Now for a 3-bit converter, if we see for a 3-bit converter, the voltage output from DAC is given by reference voltage into B3 by 2 plus B2 by 4 plus B1 by 8. Now you may have a doubt how we are going to get this equation. We know that suppose if we consider the reference voltage is 8 volt, okay, then we are going to get the resolution is equal to 8 volt divided by 2 raised to n. So 8 upon 2 raised to 3. So it is a 3-bit resistor, 3-bit converter. So we are going to get 1 volt as the minimum voltage, that is the resolution. That means for it is 1/8, every bit, the lowest bit, least significant bit is 1/8, that is the fraction of the voltage. 1/8 is the fraction of the voltage. So the lowest bit is 1/8. Then the next bit is twice, so it is 2 times 1/8, so we are going to get 1/4. Then the third bit, the most significant, because we have got only 3 bits, so most significant bits will be again twice of this, so it will be half. So this will be half. Now in the process, what is done, this bit, most significant bit is made 1 and rest of the bits are made 0, and the output voltage which we get here is converted into analog voltage, and it is compared with the incoming voltage. Now we'll come to know from the by taking an example. We'll take an example. For example, let us take an example. Let us say the incoming voltage signal is 5.2. I have given the same value in the notes also, so that there should not be any confusion. So you can take 5.2, you can take anything, any signal which is coming, and you can compare. Let us take 5.2 is the incoming voltage signal. Now what will be done in the successive approximation method, the first most significant bit will be made 1. When this is made 1, that means the signal, binary signal, is 1 0 0. We are writing here too, this is binary. So the output voltage which we are going to get here is 8 into 1/2 plus 0 plus 0. That means we are going to get 4 volt. Now 4 volt and 5/2, this will be compared. Now here what we can see is VIN is greater than V0. Whatever we have set here, MSB as 1, and the voltage which we are getting here is compared, and it is found to be, again, this is more. So this bit will be retained. The next approximation is done where this is retained because this voltage is less. So next bit is made 1 and the third bit is again 0, and compare the output voltage. So output voltage which we are going to get is again now 1/2. The second bit is made 1, so it is 1/4 plus 0, and what we are going to get here is, it is 2 plus 4, so we are going to get 6 volt. Now 6 volt will be compared with incoming voltage, and what we can see is VIN is now found to be smaller than V0, because V0 we are getting 6 volt. So this second bit now cannot be made as 1, so it is again approximated. The second bit is made 0, the third bit is made 1, and now it is compared. We are going to get output voltage as 8 into 1/2 plus 0 plus 1/8. Okay, so this will be 1 and 4, so what we are going to get is 5 volt. Okay, so for 5.2 volt incoming now is approximated as the output digital signal as 101. So that is the digital output of 5.2. Likewise, you can compare, you can find out, you can convert the analog signal into digital representation by using 3-bit converter. Now if you want to still approximate, you should go for higher number of bits, like 4-bit. If you go 5-bit, 6-bit, 8 bits, you can go, you will get the output which is going to be obtained will be more closer to the incoming voltage. Okay, that's all. Thank you.